Hey everybody. Oh wait, I'm sorry. Ah yes, the spell checker, mankind's worst invention. Welcome to CS302 assignment 5, and I say it's the worst invention because of the spell checker being so handy to us, it makes us forget how to spell. I mean, there are moments when you text people and you don't know how a word is spelled, but luckily on the iPhone or on the Android phone, it gives you suggested words, and of course, that's how you're able to correctly spell words. So, we're going to be creating our own custom spell checker, not as sophisticated as real spell checkers, but just to give us some practice on doing hash map data structure and so forth. So let's now go into the actual details to part A of our assignment. Okay, so this is going to be really just the steps involved with your assignment. This is not going to be a very hard program, so the video shouldn't be too long. At least I don't think it should be too long. Hopefully I don't talk too much in this video. So the first step is you're going to load a set of words from a file called usa.txt. I guess I forgot to put the ending quote right there, but you can hard code a file name, usa.txt, which will consist of all of the American English words. It'll be 60,000 words or so. You want to load this into, or actually store this into, a hash map or into an unordered map. And I guess I have a typo here. It's supposed to be standard STD, not SDT, but I'm not going to fix that because I think you get the idea. So you're going to take each word from this file and then insert it into your hash map. So of course, you can imagine that this map, the key type will be probably a string, and the value type is not really important. So I guess a Boolean would be good enough. So you simply read these elements in this file and store it into a hash map. And you're not going to have to prompt the user, you're going to have this file given to you and just simply load this into your map. Okay, that's your first step, so it's not too bad. So you have to just read end of file control loop for this. So for step 2, you're going to ask the user for a file name, which will contain some text. And you're going to just simply read each word from the file. Of course, you can use the input file stream input operator, which of course will skip over white space. You'll get the actual words. And the words in the file, I made sure to have no punctuation. It will just be words separated by a space and by a new line. So very simple to parse this file. And you want to verify if each word is spelled correctly. So of course you have to search. So every word you read from that file you're given, you want to sort of search to this map and see if it's in this map. If it is, then the word is spelled correctly. If it's not, you want to give the user a set of suggested words. I'll discuss that. It's actually here in this PDF. I will discuss it in detail in a moment. But for each word, you verify it's spelled correctly. If it's not, I'll put a list of suggested words. And then you do this until end of file is reached. So really, not so much to this. You can have, one end of file loop, end of file control loop to read your dictionary file into your map, and then another end of file loop that will read that file, and it will just check each word for it being spelled correctly and output the list of suggested words. So as you can see, there's not too much to the assignment. Let's go ahead and now discuss the idea of this suggested words when the word is misspelled. Okay, so for the suggested words part, so suppose the word dog is misspelled, as in, let's say if the word dog appears in that text file and it doesn't appear in our dictionary, that means we'll mark it as a misspelled word. So you want to go ahead and try to output all the words that are really one letter off. So the way we can do this is, you can see here that we replace the first letter of dog with A, B, C, D, and so forth, from A to Z or Z. Then for every letter, so for a second letter, we replace also A, B, C, and D, and so forth. Now over here, when I replace the word the word D with D for the first letter, spell the word dog, we don't want to include this into our suggested words because really, we already have dog is misspelled, although it's not going to cause any real major problem because it won't matter at all. But there's no point to add that word into your possible suggested words list. So just refrain from adding the same copy into that list. So of course, you may want to just insert all these into a vector. So insert AOG, BOG, COG, DOG, or not DOG, sorry, and EOG all the way to Z. Then for every letter, so for a second letter, same idea, replace it with A through Z, and same thing for a third one. So for every letter, replace them with A through Z. You want to insert each of these into a vector, maybe a vector of possible suggested words. And then what you want to do is you want to add a letter A through Z in every spot. So for example, we have the word dog, we add A, B, C up to Z in front of the word dog. Then we add the word letters A through Z between the first and second letter. And then we add A through Z between the second and third letter. Then we add A through Z for the last letter. So you want to add letters in between. So you want to just generate all these words and put them all into a vector. So of course, you can use anything from the string library to create this. So of course, basic string, the bracket operators to access a character, string concatenation, string insert functions, all can be used to create this. Of course, you generate this list. So that's going to be the hard part, really, is creating this list. You add them into a vector. And now you want to go ahead and verify which of these words appears in the dictionary. And if any of these words you have in your vector does appear in your dictionary, then you want to maybe insert into a second list, into a separate list of valid suggested words. So what you're going to have to do is you have to traverse this list. So look at the first word, AOG. You have to look up this word in your dictionary using the hash map find function, look up AOG. If it's not in dictionary, then maybe don't insert this word into your valid list of suggested words. But suppose, let's say if BOG is actually in your vector, in your dictionary. So after you take this word BOG and you apply that find function on your dictionary object, your unordered map object of all your words in the American language or American English language, then you want to add BOG into your valid suggested words list. And you just sort of do this for every single word. So in my final remarks, or sorry, what's it called? Specifications, I said that do not linear search anything. So you're probably be wondering, well, isn't this a linear search? Well, it's not. You're traversing a list. If you want to test which words exist in our dictionary, you have to traverse this list. But notice we're not going to linear search AOG through our dictionary. We're going to essentially use our hash find function to look up if AOG exists in our dictionary. So you can see that we're using a very fast search, but we do have to traverse this list. There's no other shortcut from doing that. So we are traversing linearly, but we're not doing a linear search on our list. So just making sure I get that out of the way. So as you traverse this list and verify which word is in our dictionary, thus making it a valid suggested word, you want to, of course, sort this list. Because, of course, for code grade, it can't really test, if your outputs are in different order, then it could be a problem. So you want to make sure we have them sorted, so that way it becomes much more simpler for code grade to test it out, or for code grade to match output. So suppose you have a vector called words. You actually can include algorithm into your program and use that sort function built into algorithm. So if you have a vector of strings called words, you actually can use the following line right here to sort this list. So we're calling sort, we're passing in the beginning, we're passing in the end. So please sort from begin to end. So all that stuff we learned early in the semester about sorting, well, it's all done by this magic function right there. But at least you know that how sorting works. This is going to actually be an n-log n sorting algorithm. It uses quicksort and does some other things to enhance quicksort is what it does. So it's going to be n-log n. So that's the only hard part of this program. So you have to insert words into your dictionary. So you're going to have really one end of file control loop to just read into your dictionary file. And of course, you can hard code that into your program. You don't have to worry about reading from the input. Just you can hard code that file usa.txt and the file loop and insert each word from that file into your dictionary object. And then a second end of file loop to read through that text file that you're going to be spell checking. The only hard part I can imagine is creating this list. So that's all you have to do. And of course, for each word misspelled, I'll put the misspelled word and I'll put all of the valid suggested words. So for specifications, of course, you have your header comments, of course, your name and all that stuff like you always have to do. Notable variables. So no linear searches allowed at all. So any kind of a search, you can of course can have multiple unrooted maps you can use. So one thing I forgot to actually mention, so it's actually here in the specifications, luckily I included that right there. But one thing you want to also do, so I'm going to talk about that in a second, but you can have more than one map as needed. So whenever you're thinking about searching a list, you don't search, you use a map to look up. You use a vector only if you have to maintain a list, like that list of these words, but you're never going to be searching this list. We're going to traverse this. Any kind of a search, use a map. So also one thing I didn't mention, but it's here in the specifications, if the word, let's say for example, the word dog, a misspelled word. Let's say if dog appears more than once in your text file, then you don't want to output dog as misspelled more than once. So you don't want to output it for every instance of the word dog in your file. So you may want to have another map that maintains all the maybe misspelled words that you've seen so far. So of course, you can look into that map, and let's say if the word dog, it doesn't exist in that map, okay, well then you can mark it and maybe add it into the map. And the next time you see the word dog again, well, you can say, okay, dog is misspelled, but oh, we've already seen this word before, so I don't want to reprocess it. So that's all there is for the part A. And of course, you want to submit a file called mainmap.cpp and make sure it's named like this because CodeGrid's going to actually verify you submit a file literally called mainmap.cpp. Okay, so let's now go into the part B portion of the assignment. Okay, so for part B, it's going to be the same program like part A, except you're going to be using a vector to store your dictionary. So for that usa.txt file, you'll read that file the same way, but you're going to just insert each word into a vector rather than using a map. And you will be only doing linear searches. So wherever you have to do searches, so think 135 mode, just linear search everything. Now I think the USA file happens to be a sorted list, but that was sort of not really planned, but I downloaded that file from a website somewhere and it happened to be already sorted, so that's kind of a bummer, but assume that it's not sorted, that USC.txt file, so you have to linear search that file. So that's going to be the only difference. And of course, let's say if you have to verify if that's, so I remember from the last example when I had the word dog, if the word, let's say if dog is a misspelled word and appears more than once, and you have to verify if you've seen that word before, dog, you'd have to create another vector and linear search, make sure if that word has already been seen before. So any kind of a search you're thinking of, you're going to have to use a vector and linear search everything. So the purpose of this is to sort of compare and contrast using a map versus using a vector. And at least for me, when I ran my program, I think the map version took about, I would say, less than a second for it to run. But the vector version took about a couple of seconds. So I definitely could see a difference. So the whole purpose is you can see that how much of Well, how much of a pain it can be to write these extra, or you can create a function, of course, for linear search, but it's sort of a, definitely a map is so much more nicer to use than a vector linear search. And you will see that it is a lot nicer, less code to write even. So it's really nice, actually, a map. So anyway, that's all. So you just use a linear search and vectors to maintain. So whatever we did in this for part A that used a map, replaced it with a vector and linear search that structure instead. So part B shouldn't take that long to create. So, and of course, you have to make sure you name your file main vec. So main vector.cpp, and of course, create another file called main map. So you're going to submit 2 source files, and there's no classes you have to write. It can all be in just one file. So it's going to require you to submit these 2. So just that way, so we can test them out individually. Now, of course, the output should be the same for both of them, but the purpose is so we can test these 2 out. So that's all, just to compare and contrast. So let's go ahead and look at the output portion and then talk about some, and also there's a written portion as well. So we'll discuss that later on as well. Let's first go over the output portion. So for the example output, I just tested out with the map version, but again, either one will give you the same output. So I compile my map, I run it. So your USD.txt file, you're going to hard code that, as I already said before. You're not going to read that file from the user. You're going to hard code that, but I'm going to read in a file and Resident Evil, which has a plot for Resident Evil games. So it lists out all the words that are misspelled. But for Capcom storyline and gameplay, when I try to use all of these possible suggested words, none of those suggested words actually were found in the map. So then we output no suggestions for those cases. Now I run this program again on Siphon Filter, so I guess I'm sort of ring of retro games. So it was a very fun game for the PS1, Siphon Filter, if you ever played that game. So here's another file I provided, which has just a set of words. That's all. It's just a document, just a text that goes over the plot of the Siphon Filter game. And I removed all the punctuations and content from the file. So we have SCSC is misspelled. Here's a list of words that are similar. So these are all 3-letter words in this case, sorted, and these are all actually in our dictionary. So these are all of our suggested words. Then here's another word, misspelled, no suggestions. Of course, the main protagonist in the game, Gabriel Logan, is misspelled, but then Lauren and Slogan are the 2 words that are similar, or they're suggested words, and they're both in our dictionary, so they're both proper. I guess this is one word, bioterrorism, so I guess unfortunately I wasn't able to, because I could have separated these 2, I suppose, but it doesn't matter, I guess. PlayStation is misspelled as well. Handheld, I guess handhold was I guess this is not found in the dictionary for some reason, so handhold. Okay, sure. And spin-offs is misspelled, and there was no suggestions for spin-offs. So all the possible suggested words for spin-offs, all those words were not found in our dictionary, so there is no valid suggestions. Then Gears, for Gears of War, we prompt the user, enter a file name, they type in gears.txt, and we parse that file. Again, there's all of that. I guess this is a very polarizing example, but this is for the New England Patriots. I was originally born in the Northeast, so I was a Patriots fan growing up. So of course, we'll see how this goes. But anyway, so there's all these misspelled words and suggestions. So then we have Rickenbacker, which is one of my favorite bass guitars I own. And this is another file right there, and so forth. So for every word misspelled, list out the suggestions, and of course, don't process the same misspelled word multiple times. If let's say the word pickups appears multiple times, don't process that word again and again. That's going to be your code. So let's go ahead now and discuss the written portion next. Okay, so written portion, you're going to have to do some runtime analysis. So you're given these 2 variables, n and m. So n is your dictionary amount, or the amount of words in your dictionary. And then M is going to be the amount of words in your text file. So for example, like gears.txt contains a set of words that summarizes the plot of Gears of War. So you have M amount of words in your text file. You also can assume that every every word has a length of O of 1. So each word length will be a constant because, I don't really think you can have sort of these giant sized words. So each word will be insignificant compared to the size of your input. So you can imagine the length above each word is constant. So given the runtimes of each scenario. So assuming we have an unsorted vector of words to maintain a dictionary. And what if we use a sorted vector, which of course implies we can have a binary search in that case, correct? What if we use an unordered map to maintain dictionary, or if we use an AVL tree? So try to give me some nice detailed explanations and some math. You don't have to do summations and so forth, but just maybe do some explanations and some math. I mean, if you give me like the runtime is O of n squared. Okay, well then my question is, well, how do you get O of n squared? So can you please elaborate on that? So try to write out some detail and explain this. So now, don't ask me the question, is this enough to write? Well, I mean, you know how much is enough. So if you had one sentence, I would imagine that would be not long enough. I mean, at least a paragraph or a few lines of a standard lined paper, I guess, would be enough at least. But I would suggest a little more than that. If you have to draw some images, maybe draw some pictures, try to do a nice runtime. Just like what I do in class when I show you guys the runtime of some of these algorithms. I try to give you nice detail with some images. Then you don't have to go that far like that, but one sentence wouldn't be enough. If you gave me like, oh, runtime is this because of this. Well, that might be some points marked off. It's not long enough. You want to give me a little more detail. So don't really verify with me if it's long enough. I mean, if you have to ask me a question if it's long enough, that probably means it's not long enough. So if you have to ask me, that means I'm probably going to tell you that it's not. So that's that. So of course, yeah, just give me the runtime for those. So anyway, I'll try to give you some points for giving it a try. I'm not going to give you a 0 for trying, but you might lose some points for getting it wrong. If you give it the old, how do we call it, the old college try, then I can of course try to give you a fairly decent grade for this. So that's that. So submit that. There'll be a separate link. So on Canvas, I'll have a assignment 5 code, which you submit your code to CodeGrade, and there'll be a separate Canvas assignment 5 written, same as one of our older assignments. So you submit this as a PDF, doc file, so forth, to that other spot. So here's a link for the images and for the, I'm going to update the video link. Obviously, this is a video of my previous one, but I'll update that here. And of course, lists of words I found on this website. So I did not construct that list. It's found right there. Also, the text for Gears of War, for Siphon Filter, Rickenbacker, and so forth was all AI generated. So I used this link right here. I typed in Gears of War, and then it would spit out this text. So it's all AI generated. So I did not generate those either. So that's that. So hopefully this video did help you out. And I guess happy coding, and till next time.